In this lesson, I'll be showing you the difference between a z-interval and a t-interval, and we'll focus in on how to use t-intervals to estimate the value for the true average from a population. Maybe it doesn't sound that interesting, but one person who thought it was interesting was William Gossett, who solved the deficiency in the z-interval formula I guess maybe around the turn of the century, like maybe early 1900s, as you can tell by his look. He worked for the Guinness Brewery and decided that in his scientific research and looking for ways to craft a better beer, he realized that there was a deficiency in the formula they were using, the z-interval formula, where you were using a standard deviation that came from a population to estimate the true average from a population. And that was based, that the standard deviation that they used in the Z formula was based on prior experience instead of the actual sample at hand. So it's likely that your teacher, maybe myself included, has already mentioned that problem with the z-interval formula. And the t-interval formula was Gossett's improvement towards it. And the adjustment that is made from the z-interval to a t-interval formula includes using the standard deviation from the sample instead of the standard deviation from the population. And because we're using a standard deviation that's not the true standard deviation, the t is replacing the z, and the t ends up being slightly larger than the z, making our margin of error a little bit larger because of the inaccuracy in the standard deviation. Now, you don't need to know all that necessarily to be able to calculate a t-interval, but that's just a little background on it. But you do need to know the difference between when to use which formula. So in both formulas, we're looking for, in this case, the true average from the population. If you're given somehow the standard deviation from the population, then you're going to be using z-scores and that number to calculate your z-interval confidence interval. If you're never given, and often cases you're not given, the standard deviation from the population, you use the next best thing, which is the standard deviation from your sample. And you're going to have to find a t-score instead of a z-score on a table, distribution table. All right, so let's actually begin with question number one. So to estimate the average new car payment, 40 random customers were surveyed and found to have an average of $550 per month. The standard deviation of the sample was $50. Develop a 90% confidence interval to estimate this parameter. Now, if you've gotten this lesson already, you may want to use this as practice time. Remember, we want to communicate our confidence interval as completely as possible, and I use a three-step process. So try this question on your own if you know what you're doing. You can pause the video and then unpause it. And if you have no idea what you're doing, of course, watch as I go through this. So here's the solution. First of all, we're going to locate what each of these numbers represents in the question. So our sample size, n, is 40. There's 40 customers. The sample average is 550. The sample standard deviation is $50. It's saying that the standard deviation is coming from the sample. And because of that, we know that we're going to have to use the t-interval formula to locate our confidence interval. And it says to use 90% confidence. The very first step in a t-interval is just like the very first step that we've used for z-intervals, is to check to see if it's a simple random sample and check to see that your sample size is greater than or equal to 30. And both of those actually check out. Next step is to, just as we did with z-intervals, in the second step, the first thing you want to do is to announce what interval you're using, and we're doing a t-interval here, and write down the formula as well. Then you can replace into the formula all the values that we know are true. So in this case here, the average was 550 from the sample. the standard deviation was 50, the sample size was 40, and the only thing we don't know at this point is what value to use for t. Sometimes, as you notice in the formula, there might be a t star there or a z star there, depending on which formula you're using. That's just a decoration for just announcing that it stands for a critical value. I usually just drop that little asterisk that's hanging on the shoulder of those z's and t's. From here, it's just a matter of figuring out our t-score. So just like we figured out our z-scores, we're going to go to the distribution table, and when we worked with z-scores, we would look for our confidence interval and use the number on the bottom, the very bottom row for our z. In this case here, we're looking for a t-score, and the t-scores are all the other numbers that appear in the middle, in the body of this table here. So to be able to figure out which of those numbers to use, you need to find two numbers. One is given to us in this case, that we're using 90% confidence. The second number you need is the degree of freedom. And as you see on the table, there's this df sitting there too. We have to make a decision on what degree of freedom to use. So to calculate the degree of freedom, it's a very simple formula that you have to memorize. The degree of freedom is n minus 1 in this case. So if there's 40 in our sample, the degree of freedom we want to look for is 39. And sometimes we'll see that number on the table, and sometimes not. In this particular case, we don't see a degree of freedom of 39. So we're going to have to use the next best thing that's on the table. So we're going to be using 90% confidence, which is what the question asked us to use. So we're going to be using this column right here. And we would want to use 39. 39 is not on this list for the degree of freedom. Common sense says maybe we should use 40. Technically, you're supposed to actually go, officially, you're supposed to go to the next lowest number that's on the table. If we're bold enough to say it's 40, then we're going to be using a smaller number for the t-score, which makes our margin of error smaller, but we want to err on the side of caution and make our margin of error larger. So we want to use a bigger t. To use a bigger t, we're going to have to use a smaller degree of freedom. So the rule is basically if you do not see your degree of freedom on the table, then go to the next one that's lower than it. So in this case, since we want 39, we're going to use 30, and we're just going to read across there and use the number where the column and the row both meet. So 1.697 is the number we would use there for t. Putting that number in and calculating the margin of error by multiplying and dividing gives us a margin of error of $13. So 550 plus and minus $13 gives us our confidence interval between $537 to $563 would be our best guess of where the true average car payment would be. And just as we did with the Z interval, you're going to want to explain what your interval means to your audience. So in this case, we would say the method used, and it's kind of a rote way to say it, but the method used locates the true average 90% of the time. My brain's thinking faster than my hand is writing. Another way to say that is that 19 out of every 20 samples that we take, that's 90%, 19 of every 20 samples we take on average should give us should be a good sample and give us a good estimate. This could perhaps be a bad sample. We would not really know, but because our confidence interval is 90%, 90% of the samples we actually take will give us a good margin, will give us a good interval that we could rely on. All right, so let's do, now that you got the basics worked out, hopefully that was correct for you. In question 2, we're going to try it one more time. And just like in question number 1, you can start the question on your own and see how it goes. Or watch me. All right, so this is how I would do it. First of all, I would have to make a decision of is the sample size and the way the sample was collected, is it proper to actually conduct a T interval or a Z interval on it? And looking at the conditions here, it is a simple random sample. That checks out. But the sample size is not greater than or equal to 30. So that's bad news for our sample, and it's bad news for our desire to actually calculate a confidence interval. We're not going to give up, though. We're going to continue on. And it would be better, of course, to have a sample size bigger than 30. If the sample size is smaller than 30, then what you'd want to do is at least take a peek at the distribution. Take a look at the box and whisker graph to see if the graph is, or the data is relatively symmetric and hopefully without any outliers. So when I plugged it into a graphing calculator very quickly, I found that more bad news, that we have a sample here that is not symmetric. It's skewed to the right. Here's the median, and there's also an outlier, one kid who did very well on the SAT. So that's bad news. I would want to record that on to my audience or to my teacher. But yeah, if it was nearly symmetric without any outliers, that would be good. That would be a better indicator that these procedures are going to work out. But we're going to continue anyway, even though the conditions aren't ripe for the confidence interval to be calculated. Next step is, just as we did before, is to name what interval you're going to be using. We don't know the true standard deviation from the population. The only thing we'd be able to get is the standard deviation from our sample. And we're going to have to get our average from our sample as well. And the graphing calculator can do this for you. So if you just want to take out graphing calculator, you can type in all the numbers into list 1, and then just go second stat. Oops. I want to do stat calculate 1 var stats. And you can tell the calculator to use list 1, but it'll automatically use list 1 anyway if you just hit enter or press second and 1. So flipping on 1 var stats there, calculating it, it tells us our average is 550. It tells us that the standard deviation from the sample is 107. This is a different standard deviation formula, not the one that we're using. And even though it has a sigma, don't be misled there. That is not the population standard deviation. That's just a different version of a standard deviation. So in this case, how would the calculator know the average or the standard deviation of all SAT scores in the school? So don't get misled and use that number. So in this case, we're just going to use SX for the sample standard deviation of 107. So you're taking those numbers there and looking up your t-score as well. Oh, but which t-score are we going to use? Well, what did I do? How did I know which t-score to use? Well, there's no confidence level that's mentioned in this question, so I decided that I was going to use 95%. That might have been where you're actually stuck on this question, if you did get stuck. I'm going to use 95% confidence. That's my own choice. In this question, it didn't say what level of confidence to use, so I use 90%. In order to figure out which t-score I need, I also need to know the degree of freedom. And remember the formula for the degree of freedom is n minus 1. And there were 10 students in the sample, so my degree of freedom would be 9. So I'm going to look up 95% and 9 on my t-table. So looking up the column for 95% and finding my degree of freedom of 9 tells me I should be using 2.262. So back to my work. Plugging in all those numbers, putting all those numbers in place, gives me a margin of error of $77. 555 plus or minus $77 will give you my confidence interval. And then the last part is just to explain what that actually means. Did I do that on the side here? Yeah. So the method used finds the true average 95% of the time. Hopefully these examples have helped you out a little bit, or at least given you a little bit of an echoing effect from the work that your teacher or me has given you so far. So you guys have a nice day, and once again, it was great to give you a little bit of a lift, to give you some confidence in how to figure out these confidence intervals.